Good morning. Today we're going to talk about arithmetic and geometric sequences. Now, a sequence is a list of numbers. 1, 2, 3, 4, 5. How about 7, 6, 2, 14, 95? Okay? Sometimes they make sense, sometimes they don't, but it's a list of numbers. Okay? Today we're going to decide what makes them arithmetic and what makes them geometric. But we need to talk a little bit about a sequence in the first place. The sequence is a list of numbers, and they're in order. And we usually call the terms, this would be a A1, A2, A3, A4, A5, and you keep on going till you get to A9. This little subscript down here tells you which term in the sequence you're dealing with. So we have some lists here. These happen to be arithmetic. This is term 1, this is 2, 3, 4, 5, 6. This one they want to be the nth term. Okay, sometimes we call them U1, U2, U3. Sometimes it's A1, A2, A3. I think we use A meaning it's arithmetic. Sometimes they'll use G1, G2, G3 for geometric. I've never done that, but it can be done. Okay, so they want us to find the next two terms and the nth term and the 100th term. Let me rephrase that. This is the nth term. This is the 100th term. Okay. Maybe not. So how do I get from 14 to 17, 17 to 20, 20 to 23? It looks like I'm adding 3. So I'm going to add 3 and get 26. And I'm going to add 3 and get 29. How do I get the nth term? Well, you take the term right before it, then n minus 1 means the one before it, and I'm going to add 3. Well, how do I know what the 100th one is? Well, how did I get the second one? I took A1 and I added 3. And then I took A2 and added 3. And A3 and added 3. The problem with this method is I have to always know the term before it, and sometimes I don't know what the 99th one is, and I sure as heck don't want to add 3 99 times. So I'm going to come up with a pattern. How did I do it? Well, I added 3 once, I added 3 twice, I added 3 three times. So the second term I added it once, the third time I added it twice, the fourth term I added it 3 times. So I've got A1 plus n minus 1, okay, the term, times the common difference, okay? So in this case, I would want 99 times 3, because 3 is what I'm adding every time. And what was my first term? 14. So I can get up my little handy-dandy calculator and figure that out. 14 plus 99 times 3 is 311. Okay? So you're going to try and find that pattern, and you'll realize that there's always, you're adding or subtracting the same amount. How did I get from, 57 to 50, 50 to 43, 43 to 36? I'm subtracting 7. So 36 minus 7 is 29, 22. This is, I take the term before it and I subtract 7. I don't want to do that 99 times. Okay, so what do? I have the first term plus n minus 1 times d, which is negative 7. And we want the 100th term, so it's 57 plus 99 times negative 7. And you get your handy-dandy calculator. And 57. Watch my handwriting. And I get negative 636. All right, y'all stop the video a second and see if you can figure out the next one. And then come back and we'll have worked it. I went from negative 18 to negative 4, negative 4 to 10, 10 to 14. It looks like I'm adding 14. Okay, so 24 plus 14 is 38. Add 14 is 52. All right, the term before it plus 14, or 14 times 99 plus the first term, which is negative 18. and I get 13,686. Okay? So that's really your introduction into arithmetic sequences. These are 4 different problems. This is the first, second, third, fourth problem. They want us to write the first 4 terms. Well, this one, they gave you the first term, and they tell you what to do. This is explicit. How do you find the next term? You add 2 to the term before it. So I start with 6, add 2, and you got your terms. This is the same thing. It's got a pattern I have to do. N is the counter, so I need, when n is 1, so I have negative 7 times 1 plus 2 is negative 5. And then I have negative 7 times 2 plus 2 is negative 14 plus 2 is negative 12. And then I have negative 7 times 3 plus 2 is negative 21 plus 2 is negative 19. It looks like the difference is 7. I'm subtracting 7, so I get negative 26. Okay? This one's back to being recursive. You start at negative 11, and I subtract 5, so you get negative 16, negative 21, negative 26. This one I have to calculate it again. 31 plus 26 times 1. 31 plus 26, 6 times 2. 31 plus 26 times 3. And 31 plus 26 times 4. So what is that? 31 and 26 is 57. I have 26 times 2 plus 31, and I get 83. And I have 26 times 3 plus 31, and I get 109. And I have 26 times 4 plus 31 is 135. What's the difference between all of them? You're adding 26. But you need this because you need to get the first term correct. And then I can call this A1, A2, A3, A4. All right? Now, given 2 terms of an arithmetic sequence, find the nth term. Well, I write these out. I have A5, A6, A7, A8, 9, 10, and 11. So this I put in 11. This is 35. So think about it. They tell me it's arithmetic. So I'm going to add something once, twice, 3 times, 4 times, 5 times, 6 times. So my little formula, it's 6 times my common difference plus the first term, which is 11. Even though it's not number 1, it's the first one in the sequence I did, I can do the math. All right, and I know I added it 6 times, right? 1, 2, 3, 4, 5, 6, and this equals 35. And then you just do the math. 35 minus 11 is 24. And now divide by 6, and you get 4 is equal to D. So now what's my nth term? A sub n is equal to 11 plus n minus 1 times 4. And that's the answer that goes right there. So I'm going to erase this, okay? You can always back up and find it again and write this down so that I can erase and do the rest of the problems. Okay, so now I'm going to erase this. That was my scratch work. I hope you paid attention, copied it. All right, same thing here. I have, I have 7, 8, 9, 10, 11, 12, 13. This is 27. This is negative 3. 1, 2, 3, 4, 5, 6. So 6 times. So 6 times D plus 27 is my first term equals negative 3. So I subtract 27, you get 6D equals negative 30. So D is equal to negative 5. So my nth term is 27 plus n minus 1 times negative 5. Okay? Now, you'll also notice this was from 13 to 7. 13 minus 7 is 6. That's how I got that right here. And then you don't have to count. You can just subtract. Okay? All right, let's get rid of that. All right, given the following information about an arithmetic sequence, identify the value of n. All right, so now what do? We know the first term is 20.5. And the formula tells me n minus 1. I don't know n, but we know this is 3.5 equals 101. So 101 minus 20.5 is 80.5. And then I divide by 33.5. And I get 23. So n minus 1 is 23. So n is equal to 24. So that's the 24th term. Okay? Okay, what about this one? Well, if I drew these out, this would be 6, 7, 8, 9, 10, etc. But I'm going to rename it as 1, 2, 3, 4, 5. How many? So what term is this? If I call this number 1, this would be 17 minus 6 is 11. So this would be A1 is equal to 47, and A11 is equal to negative 52. It's really not. We just renamed it to help us do the calculations. Okay? So rewind that, listen to that again, so that makes sense. So now I can plug it in, and you have 47 plus n minus 1 times d equals negative 52. And what did we say? We knew that was the 11th term, so let's go back and change this to 10. So d is equal to, I hope I did this right. No, that would be, I think you put in 11. Because it goes from 6, 7, 8, right? You go 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 12 terms. So this needs to be 11. I knew something was wrong. Watch that. How do you know if it's n minus 1 or n minus 2? Well, really, this is the 12th term. We lied. All right. So let's back up again. You have negative 52. Negative 52 minus 47 is negative 99. Divided by 11 is negative 9. And then we need a to the nth. Hang on. Get rid of those dots. Okay, so a to the n is, oh. So they already told us. Oh, man, so now we got to back up. We need the first term. So this is a big problem. The first term is A1 equals 11, plus 11 times negative 99. Oh, no, equals 47. Sorry. This is an 11. It's the sixth term. So to get from, this should be 5. Ugh. Okay. So I'm going to use this to find the first term, because I need A1 to find this n. Man, oh man. Is this making any sense? So this is A1 equals 47 plus 45. So 47 plus 45 is 92. Now to find what value n is, I have 92 plus n minus 1 times negative 9 equals negative 268. Negative 268 minus 92. So you have n minus 1 times negative 9 equals, negative 268 minus 92 is negative 360. Divided by negative 9 is 40. So n minus 1 equals 40. So n is equal to 41. Man, oh, let's change colors. N equals 41. Whew. That was a big process. All right, I'm going to erase again. So hopefully you took notes, wrote it down, and you can rewind and go find the answer. Ooh-wee, that was a big problem. You probably should listen to that one more time. Okay, so what do we remember from this? An arithmetic sequence is a sequence with a common difference. To prove a sequence is arithmetic by showing that n minus n minus 1 is equal to d. Okay, so a2 minus a1 equals d, a3 minus a2 equals d, etc. The recursive formula is a to the n equals a to the n minus 1 plus d. The explicit is the one we've been using, is a1 plus n minus 1 d equals a to the n. Recursive, you need to have the term before it. Explicit, you can plug in information and get it. Okay, I'm going to stop this right now and make another video doing geometric because this is really long.